Number 5. So this one is giving us some series. Look a little weird, but let's see. We want to determine if the series converge or diverge. And here you're asked if they converge, determine the value they converge to. Let's see. So start at A. We have sum n equals 0 to infinity of 2 times 1.01 to the n. And here's where we keep in mind the basic divergence test. So we have limit as n goes to infinity of 2 times 1.01 to the n. I'm taking some number. It's getting bigger and bigger and bigger. And so this goes to infinity. Oh, you can't see that, but I didn't say too much. The terms don't go to 0. In fact, they go to infinity. That's way worse, but they don't even go to 0. So the series diverges. B. So here I didn't give it to you in sigma notation, but let's see what this is really. This looks like sum from n equals, let's wait to put a number there and see what we get. So we keep raising, it's 2, 4, 8, so it looks like it's 2 to the n, 1 over, but I have to be careful because if I plug in 0 here, let's say I tried that, 1 over 2 to the 0 is 1. So this doesn't actually start at 0, it starts at 1. So the formula we know, this is equal to 1 over 1 minus 2, 1 over 1 minus 1 half, because this is the same thing as 1 half to the n. So this is just a geometric series, so we can apply this formula. And so here, for this full series, we would get 2, but because we're starting at 1, that'd be the same thing if we started at 0, and then we took off the first term, the 0th term. Right? This would be A0. So we say, okay, forget about that first term. And by first, I mean 0th term. And you get 2 minus 1 equals 1. Okay. See? 4 times minus 2 fifths to the n. This series is another one that starts at 1. N equals 1 to infinity. 4 times minus 2 over 5 to the n. That's 4. Sum n equals 1 to infinity. Minus 2 fifths to the n equals, now we have to go back, do some scratch work. So the sum n equals 0 to infinity minus 2 over 5 to the n. That's going to be equal to, and let's put this 4 here. That's 4 over 1 minus 2 fifths is, for getting a common denominator, you would get over 3 fifths, or 20 over 3. Okay, so we have 20 over 3, but we're missing the first term. Equals 1 to infinity. 2 fifths is the same thing as if I started at 0 and did this. And then I subtracted off the A0 term, which would be 4 times minus 2 fifths to the 0, which would just be 4. So this is 20 over 3 minus 4 is 12 over 3. And so I get 8 over 3 as my final answer. Okay, now it's time for part D. What do we got? Sum n equals 0 to infinity. 2 to the n over 3 to the n plus 1. So this almost looks like what we want, except these two things don't match. This almost looks like a geometric series. But this is actually a pretty simple fix. N equals 0 to infinity. I can pull out a 1/3, and this becomes 2 to the n, 3 to the n, 1/3, sum n equals 0 to infinity, 2/3 to the n. And now by definition, or not by definition, by our formula, this is 1/3 over 1 minus 2/3 equals 1/3 over 1/3, which is also commonly known as 1. All right, that's all there is to that.